So I think firstly, well, thank you to the organisers of Data Weekender. I think 6.5 came around pretty quickly. So it's really good that, well, Mikey, Kevin, Justin, Pragati, are on the case with the conference. So it's really good. And it's great to be invited to speak as well on my favorite subject, which is all of these different SQL engines in these analytical services. When I say analytical services, that's going to become a little bit clear when we look at the timeline. So I've got a bit of a timeline in terms of SQL engines. But welcome to When Two Become One, Fabric SQL Data Warehouse. Let me bring my slides into focus. So the QR code takes you to my Twitter. That's where I usually talk about Fabric, data warehousing, maybe a little rant every so often about data modeling and star schemas and things like that. I mostly blog at serverlesssql.com. So that's where all of my Synapse analytics and Fabric-y blogs appear. And there's my LinkedIn profile as well. Like I said, LinkedIn, Twitter, I'm available on there if you want to ask any questions about any of this. I'm just going to start my clock just so that I am aware of what time it is. We're going to split into three areas, really. I do want to get to the demo where we'll have a look at Fabric warehouses and some of the nice features that we've got in there. But before that, look, I just want to explore the timeline because it is interesting and it fascinates me in terms of where we are now. Yep, so Microsoft have announced Fabric. Okay, fine, brilliant, great. Where's it come from? How have we got here? Because it helps me understand what the technology can and can't do from where it's come from. And I don't know, maybe a little bit of a hint about where it's going as well. We'll touch on lakehouses just as a comparison. I don't have anything heavy in terms of lakehouses. That's going to get covered in other sessions, but I want to put lakehouses next to warehouses so that we can understand a little bit more of what should we use in what scenario. So in terms of the timeline, this is really something that started 20 years ago. In terms of the timeline, if we're going to trace the roots of Fabric SQL back as far as we can, we're going to start at a company called Datalegro, started by a guy called Stu Frost, who's still, very much active. He works in AI. He's very much a kind of a founder startup. But 20 years ago, which sort of makes me feel a little bit old now, he started a company which specialized in creating a large-scale multi-terabyte data warehouse platform. Got some customers, rolled it out. I'd say that it was a bit of a disruptor in the market against the large-scale platforms and very expensive platforms that Teradata, Oracle had. Microsoft didn't really have anything in the space in terms of multi-terabyte large-scale data warehousing. So guess what they did? Of course, they bought Datalegro and they brought SQL Server into the mix, and we got Parallel Data Warehouse, PDW. And that was 2008. So that was Parallel Data Warehouse, SQL Server 2008. Now, this wasn't software that you could just download and install on your laptop like SQL Server. I can go onto the internet, I can download a version of SQL Server Developer, I can install it. Brilliant. Developer edition of SQL Server has all of the features that Enterprise has, so I can get hands-on with all of that. Parallel Data Warehouse, no, this was something that you needed to install on specific hardware. I think at the time only Dell and HP supported installing Parallel Data Warehouse. You had to have Microsoft and consultants come and install the software on commodity on specialized hardware. Very good for huge data warehousing, the concept of separated storage and compute. What comes next? The cloud, Azure SQL Data Warehouse. Now I'm going to put in brackets modified SQL Server. Ultimately, under the hood, this is all coming from SQL Server, but it's advanced, it's modified. Whereas SQL Server, itself is very much, a symmetrical, an SMP-based system. Parallel Data Warehouse, Azure SQL Data Warehouse are MPPs. They're parallel processing, massively parallel processing systems. The benefit of Azure SQL Data Warehouse was now, yes, it was in the cloud, but we could get our hands on it. We could provision a SQL data warehouse. You were being charged by the hour and by the terabyte of data that you had in it. But for low cost, you could get involved and you could start to use it. Very good for companies who, quite frankly, were not really going to get involved in Parallel Data Warehouse because that was a significant investment. And training. It was a departure from SQL Server. Azure SQL Data Warehouse gave you access to that. At the time, Gen 1 or Generation 1 of Azure SQL Data Warehouse was rolled out, and in terms of the compute tiers, you could start with a single node, 24 gig of RAM. They did advance it and they brought along Gen 2 and we got 60 gig of RAM. So 2.5 times the RAM, plus they modified the memory within the data warehouse to make it more efficient. What happens next? So Synapse came along, in 2019. So we've got about 5 years roughly between each evolution of the product. So we've got Gen 2 of Azure SQL Data Warehouse got rebranded or renamed as Dedicated SQL Pools. So my poor old Azure SQL Data Warehouse got renamed and put alongside other services. It largely remains the same. We got a new engine. We got Serverless SQL Pools. There was a white paper many years ago, or sorry, a few years ago, called the Polaris white paper, which talked about a fault-tolerant, multi-node, automated or automatic distributed engine for data processing. Ultimately, the engine that Microsoft wrote for Serverless SQL Pools was based on this concept. When you run a SQL query in Serverless SQL Pools over data that sits in a data lake, the engine calculates, well, how many nodes, how much compute do I need to run this query? And I'm going to scale out, meet the demands of this workload, and I'm going to deliver the results back to the client. This is where we start to deviate slightly from all these other technologies, in that we don't really have much control over Serverless SQL Pools. We can't allocate a certain number of nodes or a certain amount of compute. We could do that with Dedicated SQL Pools. We can do that with Azure SQL Data Warehouse. We can say, right, I want to run, based on what I know about my workloads, this amount of compute. Serverless SQL Pools takes that away. So it's a bit disconcerting. You are ultimately trusting the engine to do the best it can to get the results back. So when you're performance tuning something like Serverless SQL Pools, yes, there are recommended practices to follow, but you have to analyze your workloads and work with your specific workloads to find what works best. It's not just about setting it to a specific amount of compute. This is kind of where the journey ends for dedicated SQL pools. We now move into Fabric SQL. One of the biggest complaints of Synapse Analytics was the fact that you had multiple SQL pools. Great for consultants who could explain to the nth degree which SQL pool to use in which scenario, but people said, okay, I've now got two SQL services with their own options, their own ways of working with data. So I've got to understand these two different engines, and they couldn't talk to each other. They could via a proxy of having data in a data lake, but you couldn't use dedicated SQL pools and query serverless. You couldn't use serverless and just query data that was sat in a dedicated SQL pool. They were separate. Irritating. With Fabric SQL, what we have now is more based on that serverless SQL pools engine. So both the warehouse service within Fabric, which is a SQL-based service, and the SQL endpoint within the lakehouse, it's all running on this single SQL engine, which abstracts away the control. So you can't set anything to say, well, this is how much compute I want to run in SQL. That's all being abstracted to a higher level in terms of the Fabric compute itself. So there's the timeline in terms of how we've kind of got to where we are. I did actually reach out to Stu Frost. I was just quite interested. I asked him a few questions. So I've only got 3 questions. I asked him why. So why did you create, Data Allegro? And he saw an opportunity. People saw the cost of those large scale systems and thought, oh, okay, that's quite prohibitive. I asked him what happened when Microsoft bought Data Allegro, because you never know. I'm hoping it was a welcomed purchase of the company. And actually, Stu stayed there. So he stayed there for a couple of years, and he was involved in the parallel data warehouse in its inception. And the last thing was, I asked him, what would you say to yourself if you could go back in time and give yourself some advice? And he talked about the cloud. Interestingly enough, he mentions Snowflake. I think he likes the Snowflake way of doing things. Now, in terms of Fabric, I'm not going to go into too much detail about what is Fabric. That's a whole session in and of itself. That's a whole training day in and of itself. But I want to cover some key points. That GitHub URL, if you go to that URL, Microsoft have released a whole bunch of resources, slide decks, everything to do with Fabric. So if you want to go and take those materials, create your own presentations, maybe for your organization, they're all there and they're very good. The way I look at it is that it's added significant functionality to a Power BI tenant. I think that's how I'm approaching it, because I'm more of the data warehousing side of things. What's interesting is you look at the product Synapse Analytics, and what Microsoft did there is they tried to integrate some of the Power BI features into the world of data warehousing and data engineering, and then expected people to use the Synapse Studio, the web portal. What I found is, yes, data engineers, data warehouse professionals, they would be using Synapse Studio, but they'd also be using Power BI as well. They might be modeling data. Anyone who was using the Power BI portal, data analysts, never really used the Synapse Studio. Why would you? So I think Microsoft have done it the other way around. They've taken the Synapse parts and they've moved them into Power BI. Yes, it is software as a service. So all of that, control has been taken away from you to a certain extent, whereas Synapse is platform as a service. You don't purchase servers, you purchase compute. And we've got another acronym, CU, capacity units. Premium, or a P1 Power BI tenant, is an F64. Now, the reason that we've got a high number in terms of an F64 is that these SKUs, or these tiers, go all the way down to an F2, which is a tiny compute. Still gives you all of the functionality that's available within Fabric, but you've still got some of those licensing constraints in terms of distributing content to free users, where you're going to need to be on that F64, that P1. Spark is configurable, so you do have some control. So when you create a Power BI/Fabric workspace, yes, you can go in there and you can create new Spark pools. You've got small, medium, large, extra large, extra large, with all the different V core sizes that's available. Install libraries into the Spark cluster. So that's configurable in terms of compute and power. But the SQL side of things, that's the compute that's been abstracted away from you. And the biggest departure in terms of a SQL-based service that Microsoft have produced is the storage. So the storage in the warehouse is underpinned by Parquet, these column store based files. We'll have a look at those a little bit in the demo, but it's based on Delta Lake. So Delta Lake is that intermediate service between the compute and between the storage, which helps us with transactional consistency. Metadata management. Now, the way that I also explain some of the Fabric items in the portal is looking at workspaces. So there we go. On the left-hand side, I've created a workspace and it's called, wow, there's a lot of things here, because yes, there's a lot of things there. I can create in a single Fabric workspace a data pipeline, a Power BI data set, a streaming database, KQL database, a lakehouse, a machine learning model, a notebook, a warehouse. Lots and lots and lots of things in that workspace. But what is a workspace in terms of the warehouse and the lakehouse as well? Well, let's open good old trusty SSMS, SQL Server Management Studio. Other SQL clients are available, of course. We see that workspace like a server. So whenever I explain permissions, whenever I explain how these things are put together under the hood, I say a workspace, it's a little bit like a server. Yeah. So when we log in using Management Studio or Azure Data Studio to the URL of the workspace, we're seeing a server. Now, in terms of the differences between lakehouses and warehouses, so the first thing is, well, icons, right? Gotta love some icons. We now have colored icons available within the portal, which is good, which is a good thing. Lots of discussions around the color coding. But what we have at the moment, it's split into two. We've got the persona and we've got the actual item icon itself within the workspace. The persona for the lakehouse being the data engineering persona, the persona for the warehouse being, well, a data warehouse persona. What are we using the warehouse for? So we're using the warehouse for structured data, tabular data. We've got tables, we've got columns, we've got rows. In the lakehouse, we're dealing with that structured data. Yes, tables, columns, rows, but we're also dealing with unstructured data. Save your audio files, your video files, your documents, anything to the lakehouse files section, and then your machine learning developers, your data scientists can use all that unstructured and semi-structured data in their machine learning models. And this is probably the most important thing, is the profile of who is using these services. Lakehouse, yes, we're in the world of Spark, so we're using PySpark, we're using Python. Yes, there's support for Scala, but it's the data engineering. Yeah, if we want to bring our code-based loading processes with PySpark, if we want to use notebooks to do our data loading, our data cleansing, we're going to go to the lakehouse. The warehouse, on the other hand, is SQL based. Yeah, we are using SQL. Lots of discussion at the moment about the medallion architecture. And look, I'm not going to go into the debate now about what all these layers can be called, but lots of documentation, including Microsoft themselves, refer to bronze, silver, and gold. Bronze being your raw data, the data that you do not modify. You've loaded that in untouched. Your silver layer is where you've cleansed the data, maybe deduplicated it, data quality checks, augmented it with other data, master data, for example. And then your gold layer, you're presenting it. So that could be aggregates, could be a star schema, however it is that you're presenting your data to hopefully a business intelligence tool to report on it. You could do all of that in the lakehouse. In the warehouse side of things, we're just going to use it really for the gold layer, for that presentation, that star schema. Not really going to use it to hold the raw data, right? So it definitely has its place. And of course, you can mix and match. Your lakehouse could be your raw and cleansed. Your warehouse could be your presentation layer. Now, yes, Direct Lake is a new mode which gives you not quite import level speeds within a Power BI data set. Close enough, without having to move that data in import mode. So we've kind of got the benefits of direct query and import mode. At the moment, it's only available within the lakehouse ... Maybe if you'd like to check out Microsoft Ignite next week, who knows? But on the warehouse side of things, at the moment, we've got direct query and import mode. But hint, hint, go and watch Ignite next week. So in terms of powering the warehouse, yes, we've got this auto scale out distributed engine that we don't have any control over. Yes, it is an enhanced version of the Serverless SQL Pools engine. It uses Delta Lake. I would have loved to have been in that meeting at Microsoft where they decided, you know what, let's go and use Parquet. Let's go and use Direct Lake as Delta Lake as the storage mode of our SQL engine. Wow. Ultimately, in the storage layer, we're going to see the things that Delta Lake creates. So we're going to see a Delta log. we're going to see folders with Parquet files in, right? So Microsoft haven't messed around with that. So if you've got a Databricks process, or you've got a process, a Spark process that is writing to Delta, you're going to see the same construct. You're going to see some transaction logs, and you're going to see some folders and some data within that within those folders, and including that Parquet file format. That the way I always describe it is it's a file-based version of a column store index. Yeah, it's storing data using column store compression, really, which is why you get a very high level of compression within these files. In terms of loading options, code, I've said it's SQL, right? We can use the copy into commands. This was the go-to command for dedicated SQL pools and for Azure SQL Data Warehouse. It offered the best performance for importing data into Dedicated and Azure SQL Data Warehouse. And it's available within Fabric, and Microsoft say, if you can use it, use it. Not very nuanced, but it's fast. We can use CTAS, so we can create table as select. So if we've got a whole bunch of data that we want to bring in, we can just use a create table as select and bring it in. We can insert into, so we can insert using values, using a select. What I would say is, this isn't SQL Server. Well, it kind of is. It is not for transactional workloads. It is not for singleton inserts. You are going to see quite bad performance in terms of inserting a single row of data. This isn't an engine for that. This is an engine for analytical purposes. But you can still use inserts for metadata. And, well, if you've got code in notebooks, you've got Python, Scala in notebooks, you can use PyODBC to work with tables in the warehouse using data frames. There is some cross-pollination there as well. If we come to the low no-code options, yes, we've got trusty pipelines. So we've got copy data, so we can, bulk load data into warehouse tables there. Yes, we've got data flows Gen 2, and we've got an append and a replace option. So it's either going to replace the data that's in the table, or it's just going to append if you know that all the data that's coming in that particular flow is new data. So we're going to flick to a demo. So before that, are there any questions before I fire up Fabric and Data Studio? I'm just having a little look.
Don't see the questions in the chat.
No, lots of blue sky code
Spam,
invites.
Yeah.
Okay, right. So what I'm going to do is I'll open up Fabric. Again, I don't want to get too much into how to enable Fabric. That's covered in other sessions. Okay. Suffice to say that what I've done is I've created a warehouse. So I've got this warehouse here. So DW warehouse. I've also created a lakehouse because I want to show one of my personal favorite methods of loading or accessing data and loading into a warehouse. But the way that I created those is I can switch to the personas. So there we go. There's our data engineering and data warehouse. On the data warehouse side of things, oops, sorry, go back to Data Weekender. I can just click new warehouse, give it a name, and it's going to create me a blank warehouse. If we open up the warehouse, excuse me. Yes, I've already got some SQL queries created. We'll leave those because they're just for the demo purposes. But this is a blank warehouse. There's no tables, there's no views, there's no store procedures. It's empty. Now, yes, you can jump in, click on a SQL query and start your create table statements. However, if you want to do things properly, let's actually use an environment in which we can source control our schema. So in Azure Data Studio, I'm going to check the about. So you're going to need to be on version 1.46.1. Latest updates, probably more than that now. In terms of extensions, you're going to want SQL database projects. So that's version 1.3.1. What that enables us to do is create database projects for Fabric warehouses. Also, serverless SQL pools for Synapse as well. Notoriously difficult to source control previously. Kevin Chant, Kevin's my go-to in terms of source controlling and CI/CD for anything Synapse and Fabric. But I appreciate the fact that I want to be able to source control my schema. So in terms of database projects, I've already created a database project, which was SQL Server. And in that target platform, there we go. There's Synapse Data Warehouse in Microsoft Fabric. Great to see that whilst Fabric is in public preview, they've added support for this. I waited 2 years, 2.5 years, maybe even 3 before there was SSDT support in Visual Studio for Azure SQL Data Warehouse to source control the schema. Great to see it's here. I've created some tables. Okay, so I've got create table statements. And what I'm going to do is publish. So I'm going to build it first. Validate the project model, and there we go. Build succeeded. Great, good stuff. So I'll right click and I'm going to publish. What I'll do is I'll just select my server, connect up to the Fabric warehouse. The connection is this big old endpoint that is available in Fabric. So we'll show that. But bearing in mind, that's the connection to the workspace. So what I'll do is I'm going to click, well, actually, I'm just going to check something on my publish options. So I'm going to untick drop objects not in source. What Microsoft have done is Microsoft have added some system views to get some statistics about your warehouse usage. And if those views are not available within my database project, therefore I don't want to drop those. And I probably couldn't anyway. But look, we're in the world of a DAC pack. We're in the world of a schema. Brilliant, great. I'm going to be honest, this is now how I work with the warehouse and schemas within Fabric warehouses. It's sometimes I'll go into the web interface and I'll just create a table and maybe do a little bit of testing. But I would say most of my time is now spent in Azure Data Studio, right? Because I can source control it. Yeah. So you can see, Git has sprung up with a load of changes for me to commit. I'm not going to do any of that. What I'll do is I'm just going to open that. Now, if we flick back to Fabric, we can see that we've got a little spinny wheel and we've got our tables. Very simple. Yeah, single fact table, 3 dimensions. All right. Good to see that it's a first-class citizen in terms of CI/CD processes. Brilliant. So back in Azure Data Studio, we'll just step through some of the ways that we can load data within the warehouse. So we've got this copy into. I'm specifying the columns that I'm going to use, well, the columns that I'm going to insert into that table. I am referencing a Common Garden Azure Data Lake Gen 2 account. It's a CSV file. All the rows start from the second row. First row is a header. So I can run that. But let me just select the connection to warehouse. Let me connect and I'll run that. There we go. So bang, 4,000 rows. It's not a lot, but it did it in about 1.6 seconds. Copy into, great. Fully recommend copy into as my favorite way of getting data into a system. Yes, we've got copy into. We've also got insert into, right? So, you know, if we've got a use case for singleton inserts, then we can do that. So I'll just run that. But I do want to highlight the fact that, okay, 0.85 seconds. I think ahead of Microsoft Ignite, Microsoft have been twiddling some levers somewhere to boost the performance of warehouses. That would normally take a few seconds to complete. And we've actually got it in, 0.85 seconds, which is good. Again, we're just loading data in. Now, one of my other favorite ways of of accessing data and loading it into a warehouse is a lakehouse. So if I go back into Fabric, I said that I had a lakehouse alongside my warehouse. Now, at the moment, warehouses don't support a feature called shortcuts. What shortcuts allow us to do, and I'll show you in the lakehouse, it allows us to, well, as the name suggests, literally shortcut to other data that's available without moving or copying that data. The theory is, if you have data stored in a series of workspaces, you may want access to that data from other lakehouses, from other warehouses. Instead of having to move that data around, you can just shortcut it and act as if the data was local. So here we've got a shortcut to another lakehouse. So I've got a lakehouse in my tenant where I've got a whole bunch of different data. I don't move that data around, I just shortcut to it. We've got little icons, so we can see we've got a little triangle to say that the source data is in the Delta format. And we've got that little link icon to say that it's a shortcut. But ultimately, I can just click tables, new shortcut. I'll go to my lakehouse and all of my data there. Now I did, yes, there we go. I haven't actually tried this yet, but now we have support to create shortcuts across a series of tables at the same time. That's very, very welcome. What that means is that that lakehouse can actually be queried by the warehouse. So I'm going to go into my warehouse and scroll down and look at the fact insert. So that is the 3-part naming convention to load data from the lakehouse, but not the data that's in that particular lakehouse because it's in another lakehouse. I've just shortcutted to it. So I'm going to let that run. It usually runs for about 2 to 3 minutes. Well, actually, it's going to be interesting to see how quickly it runs. Everything seems to be a lot. Maybe Microsoft knew that I was presenting on Fabric warehouses, so they decided to increase the compute. So yes, I find value in being able to use lakehouses and the shortcut functionality within lakehouses to be able to feed into warehouses. Yeah, it's just metadata at the end of the day. I'm not physically moving data. I am now moving data because I'm moving it into the warehouse itself. So while we let that run, I'm going to go back to data, Azure Data Studio, because I want to look at a pretty handy, useful feature within warehouses. And this is where we start to see the benefits of the technology that Microsoft have used, which is Delta Lake. So it's not as if they created this SQL engine and just put their fingers in their ears and said, well, we're just going to create the SQL engine like we know how. They've looked at the features available in these lakehouse formats like Delta and incorporated those features within the SQL, within SQL. So for example, table cloning. So what table cloning lets me do is take a copy of the table, just create a version of it. This is all metadata. So I'm not copying any data. What this is called, Microsoft call it a what was it, a dataless copy? It's a shallow clone. It's a shallow copy where all that's being copied is the metadata, right? The table schema. What you can then do is you can modify the data, you can modify the schema. It's not going to do anything to that base table. Very useful for development purposes, for testing purposes, snapshots, backups of table, point in time. And they've just released the option to specify a point in time in which you want to take that table clone. So we've got the dim event table here. So what I'll do is I'll just run that on the warehouse. The timestamp must not be after the current time before the table was created. Because let's say that. That's 11 o'clock. What time is it? It's 10 o'clock. Right, let's try 09:55. There we go. So I can take that table clone at a specific point in time, and that exists as a copy of the table. So what I can do is I can update the development table. I'm going to run that. And then if we do a select from both those tables, okay, then, well, we've got the original table. We've got the new table with the new values. Now, I want to switch to the Storage Explorer. Let's have a look at the Storage Explorer. So this is Azure Storage Explorer, where you can connect to your storage accounts. And yes, you can connect to Fabric storage. You can connect to one lake and see what's going on under the hood with your lake houses and your warehouses. So this is my warehouse. So I've already created the connection because it takes a couple of minutes to set up. In my folder, I've got the metadata and the data itself. So if I go into tables, go into the schema, you can see that my tables have folders. Right, so let's go into the original dim event. So I'm going to scroll into dim event. Hey, look, there's my Delta log. There's my JSON, which holds the schema. It holds the transactions. It's available within the data lake. No, you can't delete this. Let's try it. I could ruin my demo right now. But let's try and delete it. Right, let me delete that. If it works, I'm going to be in a whole bunch of trouble by Microsoft. There we go. We can't delete it, okay, because it's essentially owned by the Fabric service itself. If I go into the folder, well, look, there's my Parquet file. So that contains the rows for my table. But look, I've got the clone. So if I go into there, it's got the Delta log. Now, there were changes to that table. So we've got the transaction log for the changes to that table. But we've got Parquet file. Yeah, so we've got the storage for that particular table when I did that modification, right? So let's have a look back at my fact table just to see, whoops, sorry, just to see that it completed. Oh, it's still running. Okay. That's a little odd. Not to worry. What I'll do is I'll cancel that. Maybe something to feed back to Microsoft. They're still fiddling with things. But yes, so that would be, inserting from the lakehouse. In terms of other constructs of SQL, yes, we do have constraints. However, they're a little bit funny. So I'm going to open up my constraints script, alter table, add constraint, primary or a unique key. But notice I've got this not enforced. That's exactly right. It's not enforced. So I'm saying that my date key in that date table is unique. In fact, I could insert duplicate data into that date table. So your mechanism, your loading process for getting data into that table needs to make sure that the data is unique. The table's not enforcing it. Same for foreign keys. Yeah, so I can create a foreign key, not enforced. So I could add a row to my fact table where the surrogate key doesn't exist in that dimension table. Again, the loading process is going to have to take that into consideration. What's the point of having these then? All to do with the optimizing the query. So for example, if you add a unique constraint onto a table, so let me just run those. In where clauses, in joins, once the engine finds the value, it knows that it's not going to find that value again in the rest of the data. Lock request timeout period exceeded. Okay, not sure what the problem is there. Let me run that again. Okay, so it's created the date one. Well, let's just comment out these and see if it's created this constraint. Seem to have some issue with the dim event table. No, that's no problem at all. But ultimately, yes, we can create primary keys in our tables, but they're not going to be enforced. Okay, it's for optimization purposes. So what I'll do is I'll probably take out that in terms of references. So let me add the foreign key. Again, adding foreign keys helps the optimizer. Okay, so I seem to be getting these lock request timeout period exceeded. Not to worry, not to worry. But worth calling out. So I'm not going to go into the model view of the warehouse, not really relevant for this session, but adding foreign keys in your tables in the model view, your sort of Power BI view of the model, you can see those relationships. So I would drive the relationships in the warehouse that you could see in the model via applying the foreign keys, because this gets added as metadata. When you do create relationships in the model view, it does create the foreign key in the system tables, but it's going to give it a big old funky GUID name. I like my SQL objects named correctly. So we've got constraints. Now, I want to look at transactions. I think it's the last thing we'll look at in terms of warehouses because it's important. When you're loading data, when you're inserting, when you're updating, deleting, selecting, the database engine is applying isolation levels. So even if you don't do anything in SQL Server, when you're writing your inserts, your updates, if you're not explicitly setting an isolation level, it's setting one for you. It's not as if it's not doing it. It's setting an isolation level. It's the same in Fabric warehouses. Because of the storage mechanism that we've got, Direct Lake, I keep saying Direct Lake instead of Delta Lake. I've got Direct Lake on the brain. Delta Lake provides optimistic concurrency. So it essentially uses snapshot isolation in which you can modify data and read a consistent version of that data. You can read a consistent version of the data and update. You can insert with minimal clashing, with minimal blocking. But let's have a look at that. So I've got a script in Fabric. I'm a little concerned about that lock-in message that we're getting, but let's have a look. Let's see. Right. I've got a select query. So I'm going to select from dim event, 3 rows. Brilliant. I've got put in basket, browse product, purchase product. A pretty standard funnel, right? I'm going to browse a product. I'm going to put it in my basket and I'm going to purchase it. If I'm going to update, and bear in mind, I do not have any control over setting the isolation level. It's snapshot isolation. That's it. You could issue a set transaction isolation level. It's going to ignore it, right? So at the moment, that's what we have. I'm going to run an update, and I'm going to update the dim event table. I'm going to wait for 30 seconds before I commit, because I want that transaction to be running whilst I do something else. So let me run that transaction. And then on the select statement, right, I'm going to run it again. You see, there's no locking. I can still read. It is reading the data at the point in time before that update statement was running. There we go. So nothing is going to be blocked from reading from that table. You're also not going to see uncommitted data, the dreaded, ghost data. Let's have a look back at that update script. Okay, 1 record updated. So let me go back and run that. Okay, so there we go, browse page. Okay, so we've seen the update when it completes. Brilliant, brilliant. However, bit of a problem with update. Let's go back. And in fact, what I'm going to do, I'm just going to add an S, right? So I'm going to go back and I'm going to update the same record. I'm going to run that update. So there we go. I've initiated my workload and I'm going to update some records in my warehouse table. However, another process comes along, updates the same table. So I'm going to run that. That should immediately succeed. We'll go back to our other update statement that will still be running. Yeah, because we've asked it to wait for 30 seconds before we commit. We're going to see an error message. Snapshot isolation transaction aborted due to update conflict. What's happened is you've initiated an update on a table, which is going to modify metadata in the Delta Lake. Whilst that update is running, we run another update. That update succeeded. It's the first past the post. It is not who started the transaction first. It's which transaction gets committed first. Of course, that's then modified the metadata in the Delta Lake, and the warehouse has said, no, I can't modify this old update statement. So you're going to get some conflicts. Inserting, on the other hand, is where we get our proper optimistic concurrency. So what I'll do is I've got an insert statement. It's 30 seconds. Yeah, so I'm going to initiate a transaction, insert into that table. So let me just run that. All right. So I've got an open transaction on that table where I'm inserting data into. Let's go to the other insert statement and run that. There we go. So we've got that record. Actually, if we go to the select statement, we should see. Oh, there we go. So we've got that record already there. Go back here and let's see what happens. I'm going to eat my words if it fails. Succeeds. So inserts, because the underlying storage, the Parquet files, are immutable in that they don't go back. They're not modified. Inserts can just create new Parquet files. That's not going to clash. If I go back to my select statement and run, I'm going to see those 5 rows. So in terms of transactions in the warehouse, it's going to be the updates and the deletes that are going to cause you the most issues. The inserts and the selects, no problem. Updating data in the warehouse depends on how much data you're updating. It might actually be better to rewrite the table out if you're going to be modifying a lot of data. Again, it's all about your workload. It's all about understanding your workload and the patterns available here. But that's what I wanted to cover in terms of the warehouse and what we can and can't do. We can source control it in Azure Data Studio. I wholeheartedly recommend doing that. You can source control it in your Git provider of choice. We can insert data in a variety of ways. We can create constraints that don't really constrain, but help the optimizer and can help us visualize relationships in the model. But we do have to take care about loading data and what we can and can't do in terms of the transactional consistency there. So I've got blogs around isolation levels within Fabric. So I'm just going to switch back because I think it's time. I want to say thank you. So I hope it's been useful. Like I said, this isn't where I just disappear off into the sunset. I'm on Twitter, I'm on LinkedIn. Feel free to ask questions at any point. And again, thank you.